Hello everyone, this is Abrajati from the Ascend the Pathway of Education. Welcome to the another video, and this video is about the physics chapter number 1, that is the light, reflection and refraction. Okay, so as I had told in the previous video of chemical reactions and equations, I think you remember. I will be bringing the next video on the physics chapter, as we have already done the first chapters of biology and chemistry, so only the physics portion was left. So I thought that this video should be on physics. So yeah, so today we are gonna cover the physics chapter, that is the chapter number 10 on the NCERT book, but it's the first chapter you will see or you will witness about the physics. Okay, light, reflection and refraction. Okay, what is light? Anything that helps us to see the objects, that is light, the sensation of energy. Okay, so in this chapter we will get so many definitions, so some of them we will see now in the first of the chapter, then we will look for the more outermost part of the chapter. The first definition which we are going to do is reflection. Reflection. Okay, what is reflection? The phenomena of bouncing back of light when it is incident to the polished surface is known as reflection of light. The phenomenon of back of light when it is incident to a polished surface. The phenomena of bouncing back of light when it is incident to a polished surface. Okay, this is the polished surface. It is getting reflected. Okay, I am wearing the specs. This is the most clear one. I am wearing. Okay, this light is getting reflected towards you, so it is the reflection. The light is the light from the tube light is coming from towards you, that is pointed towards here. It is reflecting here. That's why only the lens of the camera is able to capture whatever is going now. Okay. The second most portion which we will read in this chapter is refraction. Don't get confused between reflection and refraction. Reflection is simply the phenomena of bouncing back of light when it is incident to a polished surface. Okay, nothing else. Okay, let me okay, first let me clear this one, reflection. I'm going to refraction little later. This is a polished surface. This is a polished surface. A line perpendicular to the polished surface is the normal. It is denoted by N. Incident ray is coming. incident ray is coming, it is forming an angle with the normal. This one is known as angle of incidence. The ray is falling into the polished surface and getting reflected so also the reflected ray forming an angle of reflection, angle of incidence, angle of reflection, and Snell's law states that the angle of incidence is always equal to the angle of reflection. Angle of reflection. The angle of incidence should be equal to the angle of reflection. This is incident ray which is falling, and the ray which is getting reflected is known as reflected ray. Incident ray and reflected. Now this second one is laws of reflection or Snell's law. Or Snell's law. Both are same. Laws of reflection and Snell's law. Okay. So there are two laws about the reflection. The first one is the angle of incidence is equal to the angle of reflection, as I told. The angle of incidence is equal to the angle of reflection. The previous diagram is I have already drawn this diagram in the previous one. Okay. So the second law is the incident ray the normal and the reflected ray all lie on the same plane. Note this one, I am again repeating. The incident ray, the normal and the reflected ray all lies on the same plane. Here it is not stating that on this plane only the three rays are falling. No, but it is stating that okay, by sideway we are seeing this a ray is falling and getting reflected. Okay, now I am giving a perfect example. Suppose you are the batsman. You are facing a ball. the bowler is coming, the ball is the ray. First, suppose it's a straight ball, it's a fast ball and straight ball, no spin, no swing, anything, no anything. Okay, the ball came and just bounced back to me. So what is that? That was in the same plane, right? I just released the ball, it went, it bounced back and again went to you. The incident ray, the reflected ray. In simple words, ball is also getting reflected after bouncing back to the pitch. Let's the pitch be a polished surface. Okay. Incident ray, reflected ray. So that one, neither it is getting after the ball is falling or hitting the pitch in this way, and after that it is getting refracted to this way or this way. It is going straight to the batsman. So that is known as the, means in that perspective plane is stated here, not like this way. It's getting this and this. Okay, I think here is the batsman standing, ball is in this way, the bowler released, dropped here, and again it's going to the batsman. Not after like this way, the ball hit the pitch and then it went this way or this way. It is going straight in this way. So it is the thing which in the second law of reflection stated, the incident ray, the normal and the reflected ray all lie on the same plane. Neither it is getting reflected to the any other way. It is going straight. Okay. Now the third portion is refraction. What is refraction? The bending of ray of light when it passes or when it changes its medium, when it passes through one medium to another medium. Suppose the diagram which is given in the NCERT book, I am showing that only. Okay. The reflection which is given into your book is air and glass. Air, glass. Air is the lighter medium than the glasser medium. Okay. Air is lighter than the glass. So what will happen? Incident ray is coming to it, falling on the surface and entering the glass. So it is also forming. It is a normal is also there. In every cases, normal is there. That reflection or refraction, normal should be there. This is normal. Incident ray is falling on it, and as the ray of light is changing its medium from lighter to the rarer, so the refracted ray will move towards normal. What if it goes straight? Like this way it will go if it's straight, but no, it will move towards the normal. So it will go in this way. It is not straight. This. It is not going straight. Instead of going straight, it is changing its way. It's bending. A ray of light is bending. Sorry. this is incident ray, this is normal, this is refracted ray, this is the refracted ray. This is the refracted ray. This is angle of incidence. This is angle of incidence, and this one is known as angle of refraction, not angle of reflection. Angle of refraction. The angle formed by the normal and the refracted ray is known as angle of refraction. Okay. So what we have to remember in the case of refraction is when the ray of light is entering lighter from lighter medium to the rarer medium, it is going closer to the normal. And what if the ray of light okay, let me show over here. Suppose the ray of light and bulb is fixed over here. A ray of light is going in this way. This is incident ray. Okay, let me bend little more. Like this way. It is incident ray. A normal is there. What will happen in this case? It will go as the ray of light is changing its medium from rarer to the lighter. It will go away. It will go away to the normal. Not it will come closer to the normal. It will go away from the normal. In this case, vice versa. Now we have seen. Now we will see the angle of refraction. Sorry, angle of refraction, not the laws of refraction. As we have already seen, reflection is also there, and some laws are also stated about the reflection. In the same way, some laws are also stated in the case of refraction, and this is known as Snell's law of refraction. This is known as Snell's law of refraction. The first one is simple. It includes some mathematical things. Okay, the ratio of sine of incidence, the ratio of sine of angle of incidence is equal to the sine of angle of refraction. The ratio of sine of angle of incidence is equal to the sine of angle of refraction. Okay. So the ratio of this and this angle, the sine, okay, suppose it is 90 degrees, not, it is not 90 degrees, 60 degrees, let it be. Then sine 60 degree of angle of incidence is equal to the, or should be equal to the sine 60 degree of angle of refraction. Okay, in mathematics, when you will learn the trigonometric ratios, then you will see the value of sine 30 degrees, sine 90 degree, and okay. The second one is the incident ray, the normal and the refracted ray all lie on the same plane. This is nothing but the same as the laws of reflection, as I had stated that the Bowler one. Okay, it lies on the same plane. The incident ray, the normal and the refracted ray lie on the same plane, the same thing. Suppose let it be a surface of water. Okay, the light is falling into it. Okay, neither after that after entering the water, neither it will get in the this way or this way. Incident ray, refracted ray. Neither the refracted ray will refract in this way or this way. It will in this way. So this one is the plane. This one is the plane. So here it is only stated that incident ray, the normal and the refracted ray lie on the same plane. Okay, so the fifth portion which we are gonna do is spherical mirror. There are two types of spherical mirror in given in your NCERT book. So those are concave mirror, convex mirror. First note down all these two. Okay, there are two types of spherical mirror, concave mirror and convex mirror. Okay, so what is the definition of spherical mirror? Spherical mirror are the mirror whose reflecting surface is curved. Thus, those type of mirror are known as spherical mirror. I repeat once again, spherical mirror, please avoid this space. Okay, spherical mirror are the mirror whose reflecting surface is curved. These thus those type of mirror are known as spherical mirror. Okay, so a diagram is given. Concave mirror, this one is concave mirror. The reflecting surface, this one, and the portion which is covered is this one. Concave mirror. Now convex. The reflecting surface is this one, the part which is covered is this one. So the light rays are falling in this side, and in the case of convex mirror, okay, light rays are falling this way, the light rays are falling and this way. Okay. So the sixth one is concave mirror. We will get to learn about the concave mirror in more details. Concave mirror. How was it looking? No need to draw this diagram, you just need to understand, because there are so many properties of this concave mirror given in your NCERT book, and also there are many there are many ways shown in your NCERT book how the rays are coming and where the rays are meeting or where the image is formed. Okay, as we know, what is the purpose of a mirror? To see our image. So where the image will be formed, so there are many cases. Okay, so we will see that. First, let me draw. Whenever you need to draw any diagram of this mirror or lenses, you need to draw this one. This is known as principal axis. This one is known as P, principal focus. This is known as center of curvature, and this is F. This one is known as focal length. Focal length. Okay, so suppose the rays are coming like this way. A beam of light is coming. You know what is the meaning of beam of light? I want the answer in the comment section. What is a beam of light? Okay, so how the rays will reflect after hitting this one, as it is curved, the ray will reflect to this. This will pass through this F, and from this way it is going you should give the arrow, otherwise it will not, it's predicting the incomplete answer. You will not get the marks if you didn't precise the arrow. Okay, so in the exam time you need to do this. So, and one more thing, suppose this is a circle, spherical mirror. The inner portion or the reflecting portion, okay, this one is concave mirror. Concave mirror. Okay, and this portion is convex mirror. This one, as I have told how convex mirror looks like. Convex. Concave and convex are the part of a spherical mirror. Concave, this part is the reflecting surface, and in the case of convex, this part is the reflecting surface. Okay. So this one is center of curvature, this one is P, this one is T, this is F, this is F. Okay, so as we have seen, let's divide this into two parts. Concave mirror, P, F, C, PFC, and so now convex mirror. Convex mirror. Now we will draw this portion. We have drawn this portion. As we have seen in the concave mirror, this part was on the left hand side, PFC. But in the convex mirror, we are seeing that P, F and C is in the right side. The ultimate one is principal focus, the focal length and the center of curvature will be inside this spherical, So we can't draw the circle like this one. We have to draw this one. If we want to draw the complete spherical, we have to continue like this. So we have to keep this P, F and C inside the mirror. So this is P, F, C. We have to remember this one. In the case of concave mirror, P, F and C will be on left hand side, and in the case of convex mirror, it will be on the right hand side. Okay, and the rays are coming like this way. Okay. First we have to draw this one, and the reflected ray will be straight to this focal. As we have seen in the in the concave mirror, the reflected ray is passing through the F. So in this case, that can happen. So the continuation of the ray will pass through it. So this is the main point. And the normal, this is also a reflection in the as I have shown in the diagram. So the normal of this is the normal. This and this angle should be equal. So this normal passes through the center of curvature. Please draw this using a scale while drawing the exam or school. Okay, it is a freehand drawing, so it is still. So this is the thing. The reflected ray will continue through this focus, and the continuation of any line, ray, we have to denote by this dotted line. Beyond the mirror. Okay. So now the image formation by concave mirror. image formation by concave mirror. There are many conditions. Okay, so the first one is concave mirror. PFC. Okay, so the first one is, suppose the object is placed at infinity. Okay, the same thing. The object is placed at infinity, so the two rays are meeting at F. Okay, so okay, let me first create a chart. Position of the object, position of the object, position of the mirror, position of the image. Now size of the image, now nature of the image. So in this case, where the object is placed, that means position of the object, infinity. Position of the image, where? At F. Where the object is where the image is formed, where the image is forming, at F. Two rays are meeting. Size of the image, highly diminished, point sized. Okay, highly diminished or point size means that it is very small. Okay, mostly we can't see. Highly diminished. Okay, maybe the handwriting is not noticeable from there, so that's why I'm repeating all this again and again. Okay, and this thing you should copy in your what to say, wherever you're trying to note all this down. Okay, you should copy all this. Nature of the image, it is real image, because it is forming inside. Okay, real image. Now it is the second condition. PFC, principal focus, center of curvature. So now let the object placed beyond the C, suppose here or here, anywhere, but beyond C, beyond center of curvature, A, B. The first ray gone like this way and reflected into S and passes through F, and the second one is, the second ray passes through C. the first ray, the second ray. Where these two rays are meeting, so here it is meeting. A dash, B dash, and it is forming in the below the principal axis. Okay, so this will be what to say, real and inverted. Position of the image beyond C, position of the position of the object beyond C, position of the image where the image is formed between C and F. Between C and F. Size of the image diminished, not highly diminished, diminished. Nature of the image real and inverted, as it is inverted, real and inverted. Real and inverted. Now we will go for this third condition. Now the third one, P, F, C, and this distance should be equal, right? Okay, it will not like that. It will, F will be here, the distance will be this, and the distance between F and C will be like this. C will be here. The equal distance should be there. Equal distance should be maintained. Okay. So the third one is at C. Let the object be at C. The object is slightly going closer to the mirror. Okay. A, B, the second ray, A dash, B dash. What will be it? Position of the object at C. At C. Position of the image, it is also at C. At C. Size of the image, same size as the object. Same size as the object. As I have not used ruler, so it is slightly the image is bigger than the object. If you will draw with the ruler, or if I use the ruler, then all these lines are straight and the diagram would be more perfect. So then in the result, both the object and image would be same. Okay, but in this case it's little okay, you have to understand, because using ruler in each and every cases is not possible, you all know. So nature of the image real and inverted. It is also real and inverted. Now the fourth condition, I hope you all are getting this, and if not, I'm repeating again. Please let me know in the comment section. I will surely make the video again to improvise. Okay. Now the fourth one. As it is going closer to the mirror T, F, C, so now let the image is between F and C. As in the previous content, it was on the C, at C, so now it is between F and C. A, B. Let the object between F and C, as I have told, this will go in this way. This is the second way, and the and that one will be, let extend this. The second ray is reflecting in this way, and the first ray, it is actually the first ray is going and reflecting in the same way. So there is as angle of incidence is equal to the angle of reflection, the angle of incidence is 0. So in the same way, angle of reflection is also same, 0. So there is no reflection. That means, yes, there is reflection, but there is no diffraction. Okay. So where the image is forming, where these two rays are meeting, this way, A dash, B dash, position of the object between F and C. Between F and C, position of the image beyond C. Beyond C. Size of the image diminished. Sorry, not diminished. Enlarged. Enlarged, not diminished. Diminished means the smaller than the object size. Enlarged means the larger than the object. Okay, so it is enlarged. Nature of the image same, real and inverted. In the last case, we will see the image will the nature of the image will be virtual and erect. We will go step by step. I hope this one is clear. Now the option number 5. PFC. One thing there is noticeable in this diagrams, as the object is coming nearer, is going closer to the mirror, the image distance as well as image sizes also, okay, the image distance is going like this way. At the first, object was here, okay, object was here and the image was on the here. As serially the object is going closer, the image is going far away than the mirror. Okay, so it is proportional, it is inversely proportional. Okay, and as the object is going closer, the object distance is also becoming enlarged, means it is increasing. At first the object was at beyond C, that is at infinity, so in that case the object was the image was at diminished size. As we have seen, the object has came closer to it, the image the object distance the image distance is becoming larger, the image is becoming larger, so it is dependent on each other. Okay, so it is dependent on each other. Now in this case, fifth one, we will see the object is present at F. Okay, so the second ray, the first ray. The image will form, but in your NCERT book is also there, the image will form, but it required a lots of space. Okay, so position of the object at F, position of the image at infinity. At infinity, size of the image highly enlarged. First we have seen highly diminished, same size, enlarged, highly enlarged. And nature of the image, real and inverted. Now we will see the sixth one. Now we will see the sixth one, and it's the least last. Okay, as I have told you, the nature of the image will be virtual and erect in the last case. So we will see how. P, F, C. Okay. So in the last case, the object will be at least its distance between F and P. A, B. So, okay, let's extend this one. the second ray, reflected ray. The incident ray, reflected ray. And then this one, as we are seeing, the rays are usually going far away from them. Okay, the rays are going far away from them, so there is no chance of meeting of these two rays. So what we will do, what happens in right now, we will see, or we will continue as I have told, the continuation part will be a dotted part. A dash, B dash. Position of the object between F and P. Position of the image beyond the mirror. Size of the image enlarged. Nature of the image, as in this case the image is neither located in this side or in the left side of the mirror, nor it is present below the principal axis. The image is beyond the mirror on the right side, and also it is present above the principal axis. It will virtual, as it is found beyond the mirror, virtual and erect, as it is not inverted, virtual and erect. This is the main funda of concave mirror, the image formation by concave mirror. Okay, now we will go to the image formation by convex mirror. Image formation by convex mirror. I think gradually my handwriting is developing. I hope so. So in the case of convex mirror, there are only two conditions, not 6 like concave mirror, but in the convex mirror there are only two. The number 1, okay, for this reason we don't have to write all this. P, F, C. Let the first one, in the first case, let the object be at infinity. Incident ray, reflected ray, incident ray, reflected ray. The continuation part of the reflected ray meets at F. Position of the image at infinity. Position of the what I told. Okay, I am repeating again. Position of the object at infinity. Position of the image at F. size of the image highly diminished or point size, as we can see the days are meeting at if, highly diminished or point size. And the nature of the image will be virtual and erect. Virtual and erect, the nature of the size will be. And in the second case, so in this case, as why there are only 2, as in the concave mirror there are 6, because the first condition was or is the object is at infinity, and the second one is it could be anywhere, as there are no P, F and C on the left hand side, as there are no P, F and C. As we have seen in the case of concave mirror, position of the object will be was at between P, F or between F and C. So as there are no, so there is simple, there could be anywhere. Suppose here, suppose here, suppose here. Okay, so let it be this one. All are same, A, B. Okay, so in this case, the incident ray the second ray is passing through this. So where these 2 rays are meeting? Here. A dash, B dash. Position of the, okay, here it is given, position of the image between P and F, that is behind the mirror. Here it is not given that is position of the object because it is not required, as I have told why. Okay, there are no P, F and C on the left hand side, in the right hand side it is there. So position of the image is between P and F. Size of the image diminished, not highly diminished but diminished, little smaller than the object size. And the nature of the image, virtual and erect. Okay, I hope this is clear to you. Image formation by both of the mirror, concave and convex. Okay. Now we will see one of the most important, or the concept you need to be cleared about that concept for solving any type of numericals of this chapter, like reflection and refraction. There are so many types of numericals will be coming. I will make a separate video on that numericals, but in each and every numerical, sign convention part should be clear to you. Okay, first as we have what to say, we know how to make a graph. Okay, what we know, this one is plus 1, 2, 3, 4, 5, and what is this, minus 1, minus 2, minus 3, like this. On the right hand side, plus 1, plus 2, plus 3, plus 4, and in this side all are minus, minus 1, minus 2, minus 3, minus 4, like this way. In the mirror also the same thing happens. Let us denote the mirror by concave mirror, or you can suppose you can denote the mirror by convex mirror also, but both are same. Concave mirror, sign convention P F C. Let the image formed in this side of the mirror. It could be anywhere between P and F, AF between F and C, C beyond C. The image should be present beyond this on the left hand side of the mirror. So what will be the position of the object in this case? What will be the position of the object in if you are asked to tell in the okay, what is the in the question? It will be given in this way: the object distance. The object distance is minus 4 centimeter, minus 5 centimeter. Okay, 1 minute. The object distance is every time will be at minus, as object is placed in the left hand side, and we have seen this in the left hand side it is always minus, minus 1, minus 2, minus 3, minus 4, everything. Let it be a minus 4, minus 5, minus 6, like this way. Okay. What if the object will never ever go in this side of this, in the right side of the mirror? So the thing which can go in the right side of the mirror is the image. So image distance can be, the image distance can be plus. Suppose the image distance is, the image is formed here, so the image distance will be at plus, as it is going in the right hand side, plus 4 plus 5. Okay. Now in the case of inverted and erect, it was about real and virtual. Now it will be about virtual and erect. Let the image obviously in this side, but on below the principal axis. Below the principal axis, what is it? Minus. So minus 5.5, minus 6.5, like this way, and it is same. It is same in each and every case. Okay. This one is plus, this one is minus 3.5, minus 4.5. It will all come in this aspect of magnification. Real and inverted will come in the aspect of nature of the image, and the in the aspect of magnification, inverted and erect will come. Okay. So as we will do numericals, it will go more clear to you, I know, but for that reason we have to practice more numericals on these chapters, and I will make a separate video on that numericals. I will make a separate video, as in the first chapter we knew that in the lecture video of chemical reactions and equations, I didn't involve any balancing equation. That those type of practice wala things required doing on board. Okay, and as I am clearing all these doubts, so I will not involve those numericals in this lecture video, because everything together can't make you clear this chapter. Everything has to be equally divided part. Okay, so this one is the sign convention part. Now these spherical lenses, till now we have seen the spherical mirrors. Now we will see the spherical lenses. Spherical lenses. There are two types of spherical lenses: convex lens the second one is concave lens. Convex lens, concave lens. It is also known as converging lens. It is also known as, that means concave lens is known as diverging lens. Converging lens and diverging lens. And one more part to say, don't get confused between lens and mirror, and the sign convention about the mirror and lens is same. Okay, in the case of lens, convex lens is known as converging lens, concave lens is known as diverging lens. But in the case of mirror, convex mirror is known as diverging mirror. Diverging mirror, it get opposite to it. In the case of mirror, convex lens becomes diverging, concave mirror becomes diverging mirror, and concave mirror becomes converging mirror. Okay, so this is very simple, but you have to remember this. Convex lens is known as converging lens, concave lens is known as diverging lens, convex mirror is known as diverging mirror, and concave mirror is known as converging mirror. It get opposite in the case of mirror. Okay. Now the 10. Now we will see about the image formation by lenses. Okay. Now in the case of convex mirror, convex mirror, suppose a ray of light, a beam of light is coming. Okay, now what is the what we will call this? Is this center O, F1 to F1? It is double of its. this one is f2, this one is 2f2, 2f1, f1, o, that is the center, f2, 2f2. Okay, so let the image or the object, let the object be present at infinity. So this is the thing. Okay, so where the image is forming in the f2 and it is highly diminished point size. Okay, now in the second case, center f1, 2f1, f2, 2f2. Okay, so let here the object be placed at beyond 2f1. Okay, here so where the image is forming, where the two rays are meeting each other, so there is no reflection over here. The thing is refraction. Okay, because the ray is entering the glass medium from the air and again it is going to the air. Okay, so A, B, A dash, B dash. The object, the position of the object is beyond 2f1. Position of the image is between f2 and 2f2. Size of the image, same size of the object, and the nature virtual but inverted. Okay, now the third one. f2 to f2. Now the object be placed at 2f1. Same, gradually it is coming closer. A, B. Incident ray, the refracted. Where the image is forming, B dash, A dash. Position of the object at 2f1, position of the image at 2f2, size of the image enlarged, larger than the object size. Okay, and the position nature of the image is virtual but inverted. Virtual but inverted. Okay. Now the fourth condition. Fourth one. Center F1 to F1, F2 to F2. Okay, so now let the image be at object be at between 2F1 and F1. Okay, what will happen here? So the two rays are meeting each other beyond B dash A dash, as it is erect. Okay, so position of the object is at between 2F1 and F1, position of the image beyond 2F2, nature of this image virtual and erect, same, virtual and erect, and the size of the image is enlarged. It is greater than this one. Okay, the things are same, but actually we have to apply our common sense. Okay, nothing is impossible. Center F1 to F1, F2 to F2. Now let the object be at F1 A B. It will meet at a certain point, but it's not here. So suppose it is meeting in this, it is going on. Okay, so what will be the image distance? Position of the object at F1, position of the image at infinity, because it is beyond our imagination. Where it will go, it will depend on the size of the object. Okay, and the nature of the image virtual and inverted, and the size is obviously highly enlarged. The size is highly enlarged. And the last one, F1 to F1, F2 to F2. Okay. So now let the object be at between center and F1, A and B. One passes through F2 and one passes through the center. Now the continuation is in the left side, as it is a lens. So it is forming image. One minute. So image is forming beyond 2f1. It is highly enlarged. It is highly enlarged. Position of the object between center and f1. Okay. Position of the object, position of the image beyond 2f1. Size of the image highly enlarged. Nature real, as it is in this way, real and erect. Real and erect, as it is not inverted, so real and erect. I hope this whole chapter gets clear to you. If not, let me know in the comment section in which part specially you guys have problem. I will surely try to clarify it in the next video. I will surely make a repeated video. As I told, I will make a separate video on the numericals where I will be discussing, where I will be clarifying each and every minute details about the numericals of both the case, mirror and lens. Okay, there are many types of important numericals you will face in this chapter, and that will surely come in your exam, because light reflection and refraction is one of the chapter from where always teacher tries to give question, especially numericals. Okay, so this is one of the finest and the most asked chapter. So in that video I will be clarifying those numericals. I hope this video is liked by you all, and if you like this video, please like this video and subscribe my channel. Please share this with your friends who are in the class 10 with your friends. I hope so this video is okay for you, and thank you everyone for being with me for a so long time. I will bring the next video very soon. Stay tuned to my channel to get all the future uploaded videos. Thank you once again. Till that, bye bye and take care of yourself.